Welcome back. This is Advanced Geometry with Mrs. RRubright. Today's lesson is 11.3, Areas of Regular Polygons. All right, in the diagram, ABCD is a regular pentagon inscribed in circle F. Find each angle measure. So we're looking for the measure of angle AFB. AFB, this angle right in here. Up in here, right? Okay. So if this is a pentagon can be divided into how many equal triangles? 5 equal triangles. 360 degrees divided by 5 is 72 degrees. So each of these triangles are 72 degrees. And then this is split into 2 equal angles, which would be 36 each. So, what is the measure of angle AFB? It is 72 degrees. So now they want to know what is the measure of AFG. So that's 72 degrees divided in half is 36 degrees. What is GAF? Well, if this is 36 degrees, 180 minus 90 is 90. 90 minus 36, 54. Identify the center, a radius, an apothem, and a central angle of the polygon. Okay, so the center of this polygon is what? P. Center is P. What is the radius? PQ is not a radius. What is a radius? A radius is, it goes from the center to what? To a side of the circle, right? To a point on the circle. That is a radius, PY. Another radius is PX. So these are both your radii. All right, so we know the center, we know what the radius are, the radii are, and then what about apothem? An apothem is a height of the polygon, the height within the polygon. So what do you guys think the apothem is here? The apothem is PQ. It is a height within the polygon. Okay, so it's like when you take each of your triangles and you drop a height in each of the triangles. Those are apothems. A central angle of the polygon. Do you guys see a central angle of the polygon? Right here. This is a central angle, right? So angle XPY. And whatever angle XPY is, whatever this angle is, would be the same thing as this arc, right? Because it's a central angle. It's an angle that has the vertex on the center of the circle. All right, so on this next problem, we're looking for the measure of angle XPY. XPY. What is the measure of this angle right in here? What do we know? We know that this is a square, and we know that we could go like this and make it into 1, 2, 3, 4. How do we know it's a square? They told us that all of our shapes are going to be regular. And if they're regular, all equal sides, all equal angles, therefore this quadrilateral, a regular quadrilateral, has to be a square. All right, so these are all 90, right? 360 divided by 4 is 90 each, which makes this 45 and 45. 45 and 45. So angle XPY is 90. XPQ is 45, and PXQ is 45. You're decorating the top of a table by covering it with small ceramic tiles. The tabletop is a regular octagon. Octagons have how many sides? 8 sides. It's regular, all equal sides, all equal angles, with 15-inch sides and a radius of 19.6. So you have to think about this being inscribed in a circle. So the radius goes to the vertex, right? That's a radius. And then if I drop another radii, Now I have 2 of them, right? So there we go. So the edge right here is 15. This right here is 19.6. All right. What is the area that you're covering? So let's look at just one of those triangles. The edge is 15. This radius is 19.6. I'm going to drop an apothem. I'm going to drop a height. When I do that, this becomes 7.5, right? So if this is 8 equal triangles, 360 divided by 8 is 45 each. But then I'm taking the triangle and I'm splitting that in half. And half of 45 is 22.5. So this half of it is 22.5. I need this height. I have opposite. I need adjacent. So tan of 22.5 equals opposite over adjacent, that apothem, that height. When I multiply by a on both sides, then I'm going to divide by this. So these essentially switch places, right? Because if I multiply by a is gone. And then I'm going to divide by tan 22.5. A equals 7.5 divided by tan 22.5. That's this height. The area of this triangle is 1/2 base times height. 1/2, 15 times the height, which is 7.5 over tan 22.5, right? That's the area of this whole big triangle. How many big triangles are there? 8 of them. Because there's 8 equal triangles, right? So I would do in my calculator, 7.5 divided by 22.5 tan equals times 15 equals, divide by 2 equals, times 8 equals, and I got 1,086.396, so 1,086.4 inches squared. There is one other option in terms of how to do this. There's a formula. The area equals 1/2 AP. 1/2 the apothem times the perimeter. Your apothem, or that height, times the perimeter, 15 times 8, 120. And it's half that. So if you did that, 7.5 divided by 22.5 tan equals, times 120 equals, divide by 2 equals, and you get the same answer of 1,086.4. It's just another formula to memorize. So instead of having to memorize that, something you can always fall back on and that you should always remember is how to divide this up. You're already having to divide it up into the 8 equal parts to get that tan 22.5 part, that apothem part. The only difference is you're dealing with what is the area of one triangle times 8 versus the area of one triangle. This is 1/2. This is your height. So instead of base times height, 1/2 base times height. Instead of one base, they're just putting all 8 bases together. This number right here, this perimeter, is really just the number of bases times 15. That's the only difference in the formula. It's just one more thing to memorize instead of just, okay, 8 times 15. That's the only difference. So if you just think of it as find one triangle times 8 of them, then you have one less formula to memorize. All right, so a regular nonagon is inscribed in a circle with a radius of 4. Nonagon has how many sides? 9. Find the perimeter and the area of the nonagon. All right, so they want to know the perimeter. Well, to get the perimeter, you need to know what this base is. All right, so 360 divided by 9 is 40. Divide that in half, you have 20 each. So we want opposite. We have hypotenuse. Opposite and hypotenuse is sine. Sine of 20 degrees equals opposite, that part of the base, over the hypotenuse, right? Opposite and hypotenuse. We'll call this like a little b. All right, so times 4 times 4. So b is 4 times sine 20. So 20 sine times 4 equals, and that's going to give me 1.368. That's half of this base. So times 2 is this whole base of 2.736 and so on. And how many of those are there? 9. So times 9. So your whole perimeter is 24.625. Okay? What is the area? 1/2 AP. You need to know the apothem times the perimeter, right? 1/2 apothem times perimeter. Or there's 9 of them at 1/2 the base of 4 sine 20 times 2, right? For the full base. And then it's 1/2, okay, so 9 times 1/2 base times height. So you still need that apothem. So let's find that apothem. That would be adjacent and hypotenuse. Cosine 20 equals the adjacent or the apothem over the hypotenuse. So 4 cosine 20. All right, so 20 sine times 4 equals, times 2 equals for the full base, times 9 of them, divide by 2, times parentheses 20 cosine times 4 parentheses equals. I got 46.3. And I'm going to do it the other way too. I had stored the perimeter. So I'm going to do the apothem of 20 cosine times 4 equals, times recall 1 equals, divide by 2 equals, and I still got my 46.3, so I know I didn't mess anything up. I did it both ways. I'm good to go. Okay, there's your 46.3. Find the perimeter and the area of the regular polygon. All right. So it's 1, 2, 3, 4, 5. 360 divided by 5, and then divided by 2 is really like 10, right? There's 5 equal, but then we're splitting it in half, so there's like 10. 360 divided by 10 would be 36, because there's 360 divided by 5 is 72 each. So like each of these would be 72. Is this making sense, guys, in terms of how you get the measurements that add to 360, a whole circle, divided by how many equal parts? All right, so the perimeter. We have this angle, we have this side length, right? Or this, the 6.5 is your apothem, and we have the radius. So we could even honestly do Pythagorean Theorem to get this, right? We could. We don't need to, but we could. So it's up to you what you want to do. You could do Pythagorean Theorem, or you could do 36. So you'd have adjacent and opposite. That would be tan of 36 equals, wow, it's not tan. Well, if I use this as my adjacent, I can use that on my side. Tan 36 equals adjacent over opposite, which would be part of the base. So you'd have 6.5 divided by tan 36 equaling your B. All right, so for the perimeter, you'd have 6.5 divided by 36 tan equals, times 2 of those is each of these bases. And then that would be times 5. So you get 89.46. 89.46 is the perimeter. And then the area of the regular polygon, you could do 1/2 your apothem times your perimeter, which you're going to store in your calculator. So keep it in your calculator. Divide by 2 equals times your apothem of